Hey, geometry class, and welcome back to another week. Today we're going to continue with chapter 2. Once again, it might feel a little bit wordy, a little bit like English class, but we're continuing to work on our logic skills as this week goes on. Then we'll move into something called proofs, okay, which are a big part of geometry class, and we'll kind of use our knowledge from this part of the chapter to help us with that. So, this first part, a little bit of review. Remember, a conditional statement always has two parts. It's got our hypothesis. Oops, that's not the best writing. Okay, sorry. It's got our hypothesis, and then it also, as you know, has our conclusion. And the hypothesis comes at the beginning, the conclusion goes at the end. Okay, now, normally we write it as an if-then statement with words. However, it can also be written using something called symbolic notation. And in this case, the first part, the hypothesis, is represented by a P. Okay, and then the conclusion is represented by a Q. So P implies Q, or you could also have P lowercase and a Q. That's a lowercase q up there. Okay, and then this symbol is read as implies. Okay, so P implies Q is the same as our if-then statement. So our conditional statement here, P implies Q, and then we also sometimes will have the converse where we switch it. So that's going to be written as Q implies P. And then if both of those are true, we can have something called a biconditional statement. Okay, we can only have that if both the top and the bottom are true. And this one is written P implies Q. It can be read either way, or Q implies P. Do you see how it's a double arrow here that it goes either way? P implies Q, Q implies P. And that is only possible if both of those are true. So let's take a look down here at the converse, or we're asked to write a converse here. So the conditional statement here, it says P implies Q. In our case, if the car will start, then the battery is charged. Okay, so our job now is to write the converse. As you can see here, Q implies P. They have it the opposite way. And we know it's going to start still with an if statement. So if, instead of the car will start, that goes to the end. If the battery is charged, then the car will start. And that would be our sentence here. Now, let's take a look at these two and decide, do we think they are true? So, if the car will start, then the battery is charged. I'd say that's usually true. The only time that's not the case is sometimes your battery's dead and someone gives you a jump start, okay? But other than that one situation, we're going to say it's true. Now, this last one, if the battery is charged, then the car will start. That's not always the case, okay? Sometimes maybe someone steals your engine, okay? If someone stole your engine from the junkyard, they sold it, it wasn't in there, that car's not going to start, even if the battery is charged, okay? Maybe you have no gas. Maybe your starter is broken, and so it can't crank, okay? There's lots of reasons why it won't start. Okay, so let's continue now. Since one's true and one's false, we can't write a biconditional statement. Now this next one. If a line bisects a segment, then it intersects the segment only at its midpoint. That is true. Remember the definition of a bisector, it cuts it into two equal parts, two sections, so it will go through the midpoint. Now, our converse over here, it will start with if once again. The Q implies P, so if a line, I'm still going to start with the word a line because I don't want to have it at the front because then it's what am I talking about. So if a line intersects the segment only at its midpoint, comma, then it bisects a segment. Okay, and once again, this is a true statement. That is our definition of what we mean when we say it is a bisector. So since both of those are true, now I can do something down here. And this is a little different. We can put the words if and only if in the middle. So back when you wrote down your biconditional statement, remember here it said if and only if. That's what goes in the middle. Okay, so when I write this, I'll say a line bisects a segment. And now instead of the then, I'm going to say if and only if it intersects the segment only at its midpoint. And we would be done with that. So notice the if and only if is implying that it can go either way. Now, just so you're aware, sometimes if and only if will be abbreviated like this, IFF. That doesn't mean if, okay? IFF means if and only if. So, if and only if, we can only write this biconditional if both of these are true. So I'm going to do another example here. Let's look at this. If the sum of the measures of two angles is 180, then the two angles are supplementary. Okay, and we know that is true. So now we need to write our converse and see if the converse is true. So if two angles are supplementary, then the sum of the measures of the two angles is 180. And once again, that's going to be a true statement. Okay, so once we have two true statements, now we can write our biconditional statement. Okay, so our biconditional statement, I don't start with if. The sum of the measures of two angles is 180 if and only if the two angles are supplementary. And that would be our biconditional statement. Okay, so that is all I'm going to ask you guys to do for notes today. If you want to practice another one right here, you can try this one on your own. Okay. There also are 5 questions to do in It's Learning, so make sure we sign in and do that. And then I will talk to you guys later. If you have any questions, please reach out. Let me know. Have a great day, guys.